Good morning. My name is Albrecht Schmidt. I'm one of the people of the steering committee of the conference, and I have the honor to introduce Kasper Hornbæk this morning, who is giving the keynote. And you are here, one keynote in the morning, and for those who have seen it, the keynote speaker went home well and arrived in Australia, so things worked out for him. And this morning we have Kasper Hornbæk. Kasper has been in the HCI community for 15 years at least, so that at least I know. It's very interesting. It's experimental, conceptual, and theoretical in an interestingly combined way. He has done really interesting stuff over the last years in the context of a European ERC project on body interfaces, and not just building stuff or trying it out, but really fundamentally thinking how this works. And he got induced into the Kai Academy this year. So this is one of the great honors of our community. So congratulations on this as well. And we're really looking forward to seeing your presentation. And I've just seen my video has gone for whatever reason, but I hope you heard me. So welcome, Kasper Hornbæk. And I think we can do sort of the waving hands clapping, because that works better than unmuting.
Thanks a lot, Albrecht, and thanks for the invitation to speak at Augmented Humans. I think these days that somehow research in our fields, at least my own work, pales compared to all of the people working in life sciences and in hospitals and our health systems, and I guess I just wanted to somehow start by saying that I hope you and your families are well, and I hope the best for your health in the coming few weeks. But anyway, let's try to get to the business of body-based user interfaces. So I'll try to discuss what I think are some of the central research problems in this area. I'll focus on open questions, things I'm struggling with, confusion, rather than sort of a very streamlined way forward, because I don't have that way, and that's not how I think about research, and that's not how like my current view of body-based user interfaces. I believe there will be a Q&A segment in the end. I'm not sort of multitasker enough to take your questions. I think along the way I'll try, but otherwise we can discuss towards the end. So at least for the past decade, we've seen these body-based user interfaces emerge in research and commercially. So for a while, people have used whole body motion to navigate maps on large displays. You can use mid-air gestures to enter text at a distance from a display, as in the bottom left-hand corner. And we can use on-skin gestures in various ways to extend the space on your forearm into a side of interaction. And of course, this conference is wonderful because it has so many examples of interfaces where the body also begins to play a different and perhaps less trivial role in interaction than, say, keyboards or mice. We also see this trend in the wider HCI literature, even more examples of what I call body-based user interfaces. And in my view, these interfaces have two characteristics. First on, they are about technology or interaction on or in the body. So the prototypical examples are implantables, on-skin user interfaces, extra robotic limbs, and so on. So this is not about mice or joysticks or keyboards, but about something that's much more tightly connected with our bodies. But these interfaces also are about how we experience the user interfaces and how we experience ourselves. So they can, for instance, affect proprioception by compression or electric stimulation. It might change our sense of balance, again, through, say, stimulating electrically around the ear, and they might affect our sense of agency. And of course, the experiences that we can create in this way are related to the body, the bodily senses like proprioception, and the links between the mind and the body. And very often people sort of motivate this work with an aim to create this sense of unmediated interaction that we could call integration or symbiosis. So in this area, there's of course work that's only about technology in on the body. There's very nice pure engineering work about body compatible electronics. And there's some work that's only about experiences with the body. There's many art projects in that space. And of course, there's normal user interfaces like touchpad screens that affect our bodily senses in a very intricate way. For me, however, body-based user interfaces are about both of these things at the same time. There's a couple of reasons why these interfaces are appealing. They dispense with the need sort of pragmatically for holding on to or looking at a device. Sean Gustafson's work on the imaginary phone is a very good example of this. They allow us to be more expressive, more accurate, more capable than normal user interfaces. For instance, it's possible to do a range of wonderful gestures on your skin compared to on a tablet. As I said before, mentioned before, they're interesting because they can actually change our experience of interaction. So in a very basic way, they can, for instance, change our experience of the locations of our limbs, as in Lopez's work, and thereby really fundamentally affect not only sort of transmission or help us transmit information to a computer, but actually change how we think about ourselves. And finally, there's a lot of body-based user interfaces that aim at aesthetic and symbolic qualities. So Christina Höeg's Soma Aesthetics work would be one example of this type of work. So again, and this will, I'll come back to this throughout my talk, some of these are about technical matters, some of these are more about experiential matters. As Albrecht said, for the past 5 years I've worked on body-based user interfaces, and in particular we have tried to use embodied cognition as the driving theory for how we approach this field. So roughly that's an interdisciplinary research area covering linguistics, psychology, computer science, AR, and many other behavioral sciences. And it has shown that our bodies and our thinking and our affective states are intertwined to a very large degree. So in particular, our bodies affect how we reason, how we remember, and how we feel. So with at least this group of people and quite a few others, I've tried to use this theory to address body-based user interfaces. So I'll give you some examples of that work, and as I mentioned in the beginning, outline some of the problems that we have been struggling with. Now, to do so, let me just make a detour and say something about what I think research problems are in human-computer interaction. So I'll just give you a very brief summary of my preferred way of thinking about research problems and use that to drive my discussion of body-based user interfaces. So that framework comes from a paper with Antti Urlasvuorta from CHI 2016. And in that paper, we tried to conceptualize HCI research as problem solving. And essentially that idea comes from the philosophy of Larry Laudan and a book called Progress and Its Problems. And in that book, Laudan discusses how to think about scientific theories, models, and artifacts. And he is very much against the idea that it's useful to think about such theories as being true or well confirmed or corroborated or whatever your favorite philosopher of science would have you say. He thinks a key issue is whether such, say, theories offer adequate solutions to significant problems. And so Antti and I try to develop that way of thinking for human-computer interaction, and in particular we talk about the problem-solving capacity of research. So in our view, the answers to research problems that are sort of interesting, or the answers are interesting to research problems, are interesting to the extent that they help or expand our ability to solve problems in human interaction with computer systems. And so that idea has a couple of components. So first of all, because of this view, we are interested in whether the problems that are addressed in research are significant. Is it a problem that's important to stakeholders, users, researchers, however we might think about stakeholders? And then there's some of the increase in problem-solving capacity that can be evaluated in different ways. So we think at least of effectiveness, efficiency, say resource use in solving problems, and in whether the solutions that answers to a research problem offers are transferable to other problem instances. And finally, all of this can, of course, be established with more or less confidence, roughly corresponding to traditional criteria of validity and reliability. So from this view, we identify or sort of have tried to see the HI literature as just consisting of 3 types of research problems. One set of those problems are what we call constructive. It's about producing understanding about the construction of interactive artifacts for some purpose in human use of computing. So it would be, for instance, they would increase our problem-solving capacity if we have no known solution and then a piece of research offers one, or if we are somehow not possible for us to implement or deploy a particular type of technology. Then there's a set of problems that are empirical, very sort of exemplified by understanding people type of papers. So this is work that expand our problem-solving capacity by describing phenomena, factors, and effects in the world and related to human use of computing. And finally, there's conceptual research problems. So those are about theories, and those are about connecting previously unconnected phenomena or theories or models about interaction. So say we have competing theories, the work that tries to sort of figure out which of those are correct when would be conceptual problem solving. So let me just use that to talk about the research problems that we are struggling with in body-based user interfaces and some high-level views of those. So as I said, constructive research aims at understanding how to construct body-based user interfaces. So it's mainly about understanding and not per se about creating artifacts. And when I think of that type of research in relation to, from my problem-solving perspective, in relation to body-based user interfaces, there's many examples of a first solution or existence proofs of particular technologies on or in the body. And I guess that is the case at all major HCI conferences, and I think that work is absolutely wonderful. From this problem-solving capacity, it's clear that there's far less work that transfers and aim to establish higher order design principles for how to build body-based user interfaces. So let me just give you just a very simple example. So menus have been researched since the 80s, at least, in human-computer interaction. There's a wealth of knowledge about how to name, organize, and interact with menus. At the same time, it's clear that people are beginning to put menus or menu-like structures on the body, starting from Chris Harrison's Skinput system, but we know next to nothing about how to actually lay out and organize menus on the body. So there's no equivalent of menu research on bodies, or at least there's very little work along those lines. So that means that there's no real guidance or understanding of how to do this in a good way. Another example I want to mention around construction is that I think there's a relatively limited work on how to do systems that aims at particular experiences. So let me give you just one example of what that work could look like, and then maybe we can argue later about whether that type of work is indeed scarce or not. So this is work done with Henning Poll, and it basically departs from an interest in how our bodies notify us. So it's clear that there's a variety of signals that we can pick up from our bodies, goosebumps, shivering, blushing, and so on, that gives us important information. And we were interested in one of these, itching. So it turns out that the psychology of itching is actually quite interesting, because it has deep relations to hygiene, and of course it can also have very external causes like bugs or irritations on the skin. So what we wanted to do was simply make a watch that makes your skin itch. I guess my dream of that watch initially would be that it increasingly itches as I waste my life on social media, and thereby sort of the hygiene aspect of itching would make me rethink how I use Twitter. But anyway, Henning constructed this watch with a custom-built electric itch stimulator. There's details and schematics at the link, and thereby we could make a very simple prototype of a smartwatch form factor that could do itching, and actually do itching with quite low power requirements. So the point here is and we did one study on that, to understand what happens when we appropriate a natural body signal like itching and compares it to something that's obviously external, like vibration in a smartwatch. So we did a study that compared these two modalities, and we had 14 participants just answer about the activation and interrupting qualities of these two types of stimuli. And I think that the results are quite clear, that itching are somehow stronger in its notification signals compared to vibration. And I think in this case that's a good quality of that type of modality. And when we ask the 14 participants a bit more in depth about about particular scenarios and whether they prefer vibration or itching, it seems, although the data is quite depending on the specific scenario, it seems that itching is preferred in more serious scenarios where you really need to notice, or where you really need to pay attention. So I showed this example because I think that the idea of augmenting, enhancing, or tapping into the body's natural signals is quite a nice direction for construction-based research. And I think this example also shows that somehow the combination of technology and careful evaluation of experiences can be quite fruitful, and there's a lot of other things in the paper with respect to the variety of different types of sensation you can actually create electrically just beyond itching. So there's quite a lot of design ideas in that. So from my perspective, I think there's many wonderful one-off prototypes, but somehow transfer, consolidation of design principles to other situations, technologies, and users are quite lacking. So any sort of higher level knowledge about building systems is not currently that frequent in research on body-based user interface. And then I guess this blending the body's natural signals and affecting the body senses are very nice forward direction. And of course, there are many people also at this conference that are already pushing this. So for the empirical research problems, the point here is that that's problems that are about creating or elaborating descriptions of real-world phenomena around body-based user interfaces, understanding the mechanisms, or describing new phenomena. And I think probably one of the most important of these questions, and one of the most under-researched ones, is very simple. When is the body better or more attractive than using a device? And of course, it's a simple-minded question, but you would expect at this stage, at least in my view, that we had good answers to it. I do believe that in other fields like tangible user interfaces, the studies and descriptions of when, say, tangibles are preferred to graphical user interfaces, or more efficient that graphical user interfaces, have proven to be quite useful. So let me just give you one slightly depressing example maybe. So on the slide is shown just a sketch of a media text entry system that I was involved in doing quite a few years ago. It was state of the art and in that way quite good. And still the performance in this case is just 59% in terms of words written per minute with your body media gestures compared to device-based input. And that's in one way quite sad, and it's also a bit depressing that we don't really know why, and we don't know how to sort of mitigate or improve these performance levels. Another example in the empirical space I wanted to give to illustrate a class of problems that I think that we don't do enough about is electric muscle stimulation. So that's been incredibly popular in the HI literature. There's also many augmented humans papers on EMS. It's been used to help you draw, interact with new objects, add haptics to virtual reality, adjust your walking, and many other things. So what is, however, quite interesting about work in EMS is that the overwhelming interest have been on technology, not on experience. And so at the time we did this study, so this is work led by Jared Knippe now at Monash, we didn't find any studies that sort of in depth had looked at how electric muscle stimulation feels. And given my two-part definition earlier of body-based user interfaces, I still find that quite surprising. So we don't know like what are the qualities of the experience of EMS, how does it differ across different stimulation parameters, and is it in one way just too horrible, bad, unattractive to be a viable interaction modality? So what I did with Jared, there's a lot of details in the paper, but that's not really important here. We created an EMS system, calibrated it nicely, and then we simply subjected participants to a lot of trials of different types of EMS. And then we used a phenomenologically inspired interview technique, the subjective experience interview with participants that departed from the question, what words would you use to describe how this feels? And we probed and developed and gathered quite rich description of this that we could transcribe and thematically analyze across participants. And so this gives us at least 6 high-level themes of experience in how people talk about being stimulated with EMS. So for instance, there are descriptions that are about autonomic sensations like twitching or cramping that are unconscious and sort of muscular reactions. There are descriptions that are mainly about surface level sensations. There are descriptions of how the sensation of EMS actually moves around your arm or moves from the interior of your arm to the surface. There's motion reactions. There are wonderful descriptions of volition and agency. And of course, there are descriptions which in one way is the least interesting, that are merely about the signals and in that sense are sort of obvious. So it's super rich data, and I'll just give you a couple of examples. So for instance, the sensations of similar to bathing in ice water after coming out of a sauna, both warm and cold. There's descriptions of how the experience of loss of autonomy when you are subjected to EMS is actually quite unpleasant and disturbing. So in addition to results like this, we can of course also take the variations in signal parameters, say frequency, and map those to experience descriptions. So here, like low frequency is very much like individual ticks and that type of descriptions. When we get up in frequency, we've seen that it seems that the experience changed to fixed continuous sensation like heaviness or external pressure. And similar, of course, we can see how a pulse width also changed the experience from something sharp to something more dull. So the point here was simply to say that in this huge EMS literature, it's not actually super clear whether we have well described what participants were actually experiencing. And I think there's some aspects of EMS that's super interesting when we look at these very close experience descriptions, and there's also some that are quite disturbing, for instance, with relation to volition and control. It's also clear that when you look at technology like EMS in this way, then you have a whole catalog, and I hope people will take up and use our paper also that way. You have a whole catalog of new experiences and sensations that are not really necessarily about moving you in EMS has been the main use, but about creating interesting sensations in and on your body. So I guess I just wanted to make the point that I think experiences are hugely useful perspective for body-based user interface research, and I think they can be quite closely tied to technology. In this imperial domain, I wanted to bring along a result that I think is one of the most interesting ones that is around with respect to on-skin input. So it's work by Johanna Bergström and previous work by David Coyle and colleagues. So bear with me, because it's sort of slightly difficult to explain briefly. But the sense of agency is a key construct in psychology. It relates to many ways of speaking human-computer interaction, like the sense of control, the sense of being a master of what you do, rather than subject to a agent that pushes you around. And in this work, we build on a paradigm from Patrick Haggard called the Libet Clock. And I'll make it short, and then we can maybe talk about that later. But the key idea is very simple. We have a complicated procedure that produces measures of agency, and that procedure involves you tapping on a foot pedal, then a clock begins moving, then you do input on either in our experiment, your skin, a button, or a touchpad, and then there's a sound, and you report how much the clock has spun around. So from this, and I'm not going to really go into this, from this you can calculate something called intentional binding, and it's all based on the idea that when you voluntarily act, your perception of time is ever so slightly compressed. And this intentional binding measure is then based on to subjects or participants very boring experimental procedure where you repeat different actions without this sense of voluntary control, and that allows us to create a measure of agency. Anyway, the key point I wanted to make here is that earlier work by David Coyle and colleagues have shown that on-skin interaction had significantly higher intentional binding compared to button interaction. So the interpretation here is that one way or the other, you feel more in control when you act on your skin compared to when you act on a button. And there's quite a few reasons why we wanted to replicate this example from this findings from David. He was also part of this paper that Joanna did, and we do find similar results, and we do find that the effect size of acting on your skin in terms of agency is large. So what's more, we have this extra condition of touchpad, and the idea here is that maybe the original finding button versus skin was just a matter of different of tapping on a button versus touching your skin. So that's why we had touchpad in this study as well. And what is interesting is that we find again a difference between touchpad and skin. So it seems to be something about interacting on your own skin that does increase your agency. Touchpad and button is not really different. For me, this is just so fascinating, and I'm super excited about figuring out more about this and how we can use this in interaction. But being able to change our sense of agency is just fantastic in my view. So to step back about those empirical questions, I think the basic, there's so many questions that remain. In particular, very basic, what is the body good for in terms of interface? I think this mapping between body-based technology and experiences that I show is a very nice way forward. And of course, there's a whole range of phenomena like balance, proprioception, interoception, and so on that we are only beginning to understand how influence the body as a user interface. So the final class of problems that I wanted to talk about, and one where I have a bit of energy, and I also think some interesting lack of findings is conceptual research problems. So as mentioned, those are sort of theory-driven problems. They're about explaining previously unconnected phenomena in interaction. They're about figuring out explanations for results that are implausible or inconsistent. And let me just try to talk about one canonical finding in embodied cognition research that I've been interested in applying to HCI, and that many others have been interested in applying to HCI. So it's the idea that body and affect, feeling, emotions are closely related. So it's been around for a very long time, from the James Lange hypothesis, almost 100 years, and some examples of work that has inspired or sustained this idea is shown on the slide. So it was believed at some time that you could stand very briefly in this expansive pose shown in the bottom right, and that would increase your testosterone level, your risk willingness, your self-confidence relative to a constricted pose, as shown on the second panel to the left. There's also wonderful studies by Kasper and colleagues that shows when you watch stimuli while you push away from yourself, you'll dislike them more than stimuli you watch while you pull towards yourself. So affect seems to be reflected in how the body moves, so we can sense that, we can use it in interfaces, and maybe we can even influence it. And that's been was actually a driving idea in my ERC proposal, and an idea that I'm very skeptical about. And part of this skepticism stems from a series of studies I did with Yvonne Jensen. So we departed from the idea of that I showed you on the previous slide, specifically also the idea of power poses, that if you are in certain poses, it actually dramatically can increase your feeling of power, your self-confidence, and so on. So what our thinking in this study was, but what if you can create interactive systems that sort of incidentally, on a less obvious way, gets people into those poses by virtue of the gestures they use? Can you then affect how people think? And of course, if you could, that would be quite impressive. And there've been HCI papers that have proposed this, and there's also been some empirical data that seems to support this idea. But anyway, so we try to investigate this systematically. So in our first study, we did very simple. You had to tap either in expansive pose on your right or in a constricted pose on your left, and then you had to answer a question of whether you feel powerful on a 1 to 7 scale. So the results for the expansive and the constricted pose are shown here, and it shows that there's actually no difference in the feeling powerful question. There is a difference in the discomfort that participants report, but not in what we were actually interested in affecting here. Of course, this is a very obvious question, so we did a follow-up study where we first of all controlled for discomfort. So we made the working spaces in the expansive and the constricted pose slightly more ergonomic. And then we used a behavioral measure of risk willingness, one of the ideas that the expansive, or one of the things that the expansive pose is supposed to affect. And that measure is very well validated. It's about pumping up a balloon, and at some stages the balloon will explode. So your risk willingness is indicated by sort of how much you are willing to pump up the balloon, and it's associated with pumps are associated with a monetary reward. What is interesting here is that, again, the difference between the constrictive and the expansive body pose are not significant. It's very small. There's some detailed analysis in the paper of these differences, but they are not significant nor practically important. So what I wanted to do with this example was to just show that in this case we find a negligible effect of body poses on behavior, or rather no effect at all. So the idea that we can influence people's behavior through incidental poses just seemed to be wrong. This was done at a time, or actually simultaneously, with a huge discussion around the validity and reproducibility of body poses. And currently, though, there's a huge new empirical literature on this, which makes it much more hard to believe in those studies. So in one way, this is also on multiple levels an indication or an example of how theory-driven empirical studies are hard. First of all, because the theory that we leaned on were actually brought in doubt as we ran the studies. And secondly, of course, because that theory can be implemented in so many different ways and can be hypothesized to have so many different experiential effects. Right. Another conceptual problem I've been struggling with for many years in thinking and in doing systems is this, I guess, seemingly clash between some conceptions of the body coming from phenomenology, Heidegger, Merleau-Ponty, and then some coming from contemporary, what you would call quantitative psychology. And I actually like and are theoretically and practically inspired by both, and are not super happy about the clash that some people see in it, and I'm not necessarily happy about the fact that some of the insights from phenomenology are not well covered in contemporary psychology. So this study is again work by Joanna Bergström, was actually an attempt to try to bridge those things. So here we wanted to quantify embodiment, and that's for some people that's almost counterintuitive, but our thinking was that I'll show you some psychology that led us to believe that's possible, and our thinking was that would be hugely useful for evaluating computer-based tools in HCI, and specifically for evaluating body-based user interfaces. So I believe many of you are familiar with findings like this in neuropsychology, where we know from neural measures from monkeys that when you use a tool and after you use the tool, your multisensory integration happens along the entire tool and not as usual just around your hand. But if you don't use the tool, or before you use the tool, there's no such integration. And the key idea we pursued here is there's actually a measure in psychology that can be used sort of on people without opening their heads that does some of the same. So it's called Crossmodal congruency effect. And it's based on multisensory integration, and it's based on interference between visual and tactile modalities. So let me just, it's a little long, but it's actually in essence quite simple. So let me just illustrate it with a mouse that controls a cursor on the screen, and we're interested in whether that mouse shows tool extension towards the cursor. So the way we do this is that we have tactile stimuli on the hand of the participants, and you have to press either of those, either of those tactile stimuli can happen. At the same time, you have visual distractors on the display in similar locations up and down. And you're supposed to ignore those visual stimuli and just react to the tactile stimuli. So then we combine the distractors and the tactile stimuli in two ways, congruent and incongruent. So congruent stimuli is when the distractor and the tactile sensation is in the same spot, either both up or both down. And the incongruent ones are when they are in different locations, either one up and one down or the other way around. And now here the idea of that cross-modal congruency effect is that if you feel tool extension towards the cursor, you're supposed to be more affected by the visual distractor near the cursor. So then we can look at the difference in reaction times between the incongruent conditions and the congruent conditions, and the larger this number, the CCE, the more tool extension you show. So this is a quantitative measure of tool extension. It can occur in degrees, and it can be integrated in a variety of tasks. So what people actually do is that they move an extended cursor around like that towards a green target. Then they use one of three conditions: a mouse, a touchpad, or just passive watching. There's a tactile stimulation, and then they use a foot pedal to indicate whether that tactile stimulation is up or down. And then they continue to go back and do this a couple of times. So this allows us to calculate this cross-modal effect across the three input devices, or the two input devices and the passive condition. And as expected in the passive condition, you actually don't see any tool extension. So that's very, very nice, and it's sort of theoretically sound. We also have shown that you can actually use this to design, let's for now call VR body-based technologies. You can use that to design different bodies in VR and know something about the extent to which they or how they affects users' experience of embodiment. So we compared a full hand, a partial hand, and an abstract representation of hands. And as expected, we saw that the realistic hand shows more tool extension than the disconnected hand, which shows more tool extension than the abstract hand. So again, this seems to be a very nice measure, because it actually separates something that for a long time we mainly talked about in qualitative terms. So the questions I on a high level is still struggling with conceptually is, like, it's very, very difficult to do theory-driven research and design. Very prominent theories like embodied interaction have been criticized for not generating design recommendations, but sort of just being an ontological background. So they don't necessarily help us as much as we would like to do. And in the case of power poses, I talked a bit about the problems of driving our work through embodied cognition research. I do think that it's very nice to be able to quantify delicate bodily phenomena, or to map or relate, as I showed with the phenomenology of electric muscle stimulation, like something very technical with quite rich theoretical description. So I think there's much more work to be done in that space. I guess that was sort of a status on my thinking about these three types of research problems in body-based user interfaces. Some open questions and some results that we have produced that I think are important and helps me think about the field. So let me try to conclude just with two high-level comments, I guess it is. So I've tried to insisting on a definition of body-based user interface that contains both experience and technology. I think as a community, I think there's much to be gained from focusing much more strongly on the experience. I think it's much more important when we use the body as a user interface, as many of us are interested in doing, than when we use a mouse or a keyboard. And I believe very good ways of doing that is mixing phenomenology and cognitive psychology and apply them to our field. And I think this systematic relation of technology and experiences, varying technology, looking at the consequences of experiences, or the other way around, as in the itching example, targeting specific experiences and exploring variations in technologies that can create them, are sort of my best suggestions for how to do that. Of course, it's also clear, but I think people are doing very nice different types of work on this, on balance, on interoception, and so on. It's also clear that the body offer unique properties, bodily sensing, bodily senses, for instance, the sense of your own temperature, the sense of balance, that we can tap much more actively in technology development. The second point I wanted to make is that I think we have a lot of work to do on theory building. So it's a bit complicated to make one slide on theory building, but my favorite author in this space is a theorician on theory called Dubin, who talks about propositions of theory. So it's essentially they're testable claims that have consequences for the world and that are precise enough to actually be right or wrong. And I think what's depressing, perhaps generally for human-computer interaction, but specifically for body-based user interface, are that there's actually quite few theoretical claims that it's interesting to disagree with. So we have few papers or authors who stick their neck out very strongly and claim something in my sense of proposition about using the body in interaction. So I think it's very difficult to find such papers. To give just one example, I mean, we've been talking about augmentation, this conference for many years, since the 60s with Engelbart, about symbiosis, about integration. Keynote done that. There's a wonderful Kai paper coming up on integration. And in much of that work, I struggle to find propositions that I can test or that I can disagree with. I also struggle to find very basic models of the body as a user interface, models that talk about the relative importance of functional, aesthetic, symbolic qualities that could somehow guide our work. And even the very basic question, when is the body good as an interface, in whatever way you want to think about that, is, to my mind, curiously underexplored. So I think there's a lot of work to do on theory building. I think some people are starting to do that. I'm myself working a lot on integration now, and I think that's very important to actually advance how we research body-based user interfaces. This concludes my talks. Thanks so much for being patient, and I'll happy to take questions in some structured form that somebody who's not me should probably organize. But thanks a lot for your attention.
Thank you.
All right. Are there any questions?
I have a question.
Yes.
So speaking with Stellark after he did his keynote, I asked him, so Kai and me, we both asked him about different art installations, and I take it my video isn't working, I'll just turn that off completely. And we asked him, oh, that was so cool, what did it feel like? And Stellark kind of smiled and said, well, the artist was suspended. We said, well, yes, but what did you feel? And Stellark said, well, I mean, I choose my words deliberately, and that's why I tend to speak to the artist in the third person. And what he explained is that from his perspective and his view of things, the relevant thing to look at is how the entire system behaves as a whole. And that he does not see his own work as being about experience. And if we would be talking about experience, that's just taking like a small subset of the entire system. And I was wondering if you had ever considered or have any ideas of how we might look at technologies, not just from a human perspective, but from a more, I'll say holistic perspective. Stellark's words were flattening hierarchies, so that we not think of what is the human experience, but that we consider how the whole system works together. And I was wondering if you had any thoughts on that.
Yeah, no, thanks. That's a good question, and I guess a good contrast. I think, so I guess in general, the way I think about interaction is that there are many competing views of interaction. You can maybe think about high-level systems. You can think about experience. You can think about our capabilities of actually getting things done. And I guess that. For instance, EMS, to a very large extent, that literature seems to me to have emphasized the ability to do new things or getting things done, and not the experience per se. I guess I'm myself mainly interested in tools for people that enables them to do to engage in activities or do tasks while feeling in control, feeling autonomous, and not feeling terrorized by technology while they engage to do that. So I guess that's why I do think about experience all the time, and think that for me it's inconceivable to not be engaging with that when we design technology. But I'm fully like, there's plenty of space for entirely other views of interaction. Say that it's about the systems as a whole, or it's about information transfer, views that sort of disregard the experience. To me, those are just different views, but it's not views that I personally would engage in actually making technology for humans use with. I mean, I can understand them for arts and for other types of projects, but I would not disregard experience in technology use myself.
Thank you.
One, if I may?
Yeah, sure.
So, looking at the work you have done and the way it's evaluated, I wonder if we as a community have to rethink our methods. I think we are running in similar things. So we are basically running these small studies, an afternoon in the lab, or people coming back 5 times. But things like that, just pick a random one, like the power pose. This is probably changing your character over the next 10 years if you use the right interaction. Whether you sit on the desk or you stand on the desk, that's going to change not sort of in an afternoon. And I think a lot of the evaluations we see, including in our papers, in a lot of papers I read, they're very artificial. They're sort of creating something, and we can only fact. So we are very good with statistics nowadays. But I think my question really is, are we basically, I think that the research direction, a lot of us agree, we go forward, we go sort of into a new realm, but we are still trying, in order to get it published, to use the old methods of evaluation, which the more I read them, the more paper I review, the more I feel it's really the wrong way we are evaluating things.
No, I think that's a very good comment, and it's one that I fully agree with. I don't think it's a question that is specific to body-based user interface. Unfortunately, I think it extends to HCI as a whole. At least I cannot think of areas of HCI where we're actually good at combining the development of novel technology with long-term evaluation. So I'm fully with you on that. I don't have any really good ideas for how to what to do, but I must admit I'm currently engaged in writing a textbook, and I read now many old HCI studies, and I must admit I'm continuously struck with wonderful studies that occurs at I mean easily over days and weeks of how early studies of how people use word processors, how they use collaborative text editors done in the 80s that were just phenomenal empirical studies. So I don't know if, like, of course there's a very complicated question, how do you design technology that has where the evaluation span is years, but I think there's probably a middle way where we just actually get our act together and do those long-term studies that they were able to do in the 80s of, like, how do you, when you really extensively train with an input technology, or where you really use a new text editors for days, what actually happens, what changes. So I think there's some of those studies we could easily do.
Do you really think that? So if you look back at the, I just get my video off to get some bandwidth. So if we look at these old studies, they would not get in any way in a CHI conference nowadays or in any of our journals. So it was very much about building new technologies, and I think a lot of it was autoethnographic, was very hand-wavy studies, but they were sort of very insightful and they gave a lot of insight. But I think completely different standard, and I think things to do with tangible facts. The question is basically, is a classical evaluation, even this long-term study over several days, several weeks, several months, is this the right thing? Or are there fundamentally new ideas in your lab how to evaluate things? So not really just basically, oh, let's run a study, but do it longer. Because I think sort of we have gotten quite fascinated with basically borrowing evaluation techniques from psychologies, which don't really fit a creative science, as I see sort of a lot of the work in HCI. Are there any ideas sort of to fundamentally change how we evaluate things?
You got cut off a bit for me, so but I think I got most of what you said. If not, please ask again. I think probably the answer is no, but I do think that maybe that's yet another import from psychology. But I do think some of those extremely low-level things like quantitative measures of embodiment or of agency does offer new ways of evaluating technology. But for the sort of the main part of your question, I'm not sure that we have new methods, but I guess we should actually just show leadership in doing those studies that might not be published anywhere, but which at least to my mind seem to be right. But I guess my main sort of methodological angle would be very low level measures right now, and maybe reviving some of those studies where you actually look at longer term use, even if longer term is not lives or decades or years.
We have another question from the chat from David Strong.
Oh yeah, I see that. What are the design challenges, guidelines of exploring a space on the body that's already dedicated for a physiological purpose? I think that's a very good question. I mean, of course, it comes up, for instance, in the studies of itching we have done, where we try to appropriate something that already have a physiological function and use it for something else. So of course, the immediate challenges is whether that overrides or those signals, or whether they attenuate them over time, or otherwise mess with those signals. And I think there's I don't know really of guidelines, but I think there's a big set of empirical questions around those issues that remains to be done. I'm not. I mean, for instance, if you now can in various ways extend your body ownership or change your perception of the space around you, so that we can have your embodied tools. I don't think anybody understands how that in the long term will affect how you think about spaces around you. So now, if your virtual body can extend to anywhere in virtual rooms, how does that actually affect very fundamental aspects of self-localization and of how you think about your space around you? I just don't know, but I think that's extremely fascinating. So I think there's a lot of very nice empirical work to be done. As for actual design advice, I don't think my head, even for itching, is sort of ready or informed enough to make guidelines. But I think that when we work with the body, this is, and that's one of the reasons why I insist on focusing on experience. It's one of the clashes that we will have all the time.
And there's a follow-up to that question also in the chat.
Okay, yeah, potential conflicts over time. Yeah, I don't. As I said, I think attenuation would be one quite annoying consequence. I think in the case of virtual reality, as I talked about, I think like just measures of workload or measures of how, or descriptions of how we change our ways of thinking about space would be very wonderful to see in empirical studies. But I think it's a very important space, but also a space where I know of very few studies that actually have been done. You're welcome. I have usually, and in particular in this setup, zero sense of time. So is it time that we conclude, or is there any final questions?
So we have recorded your talk, and I think we will upload your video later on our discussion forum, so people can still ask questions.
Wonderful.
So I think it's time to conclude.
Thanks a lot for the invitation, and thanks a lot for making it possible to actually do it still in this way. That was a very, very new and quite nice experience with all those friendly faces and animals and kids and close colleagues. So thanks a lot.